All right. We'll go through our warm-up and then jump into our new notes today. We are continuing with a non-calculator section of our chapter. So first of all, verifying our identity. Again, I always like to work with what looks like the more complex side. And this one, I would have picked the right-hand side. One of the things you can do on this one is sub in for your 1 minus sine squared. It's Pythagorean identity. 1 minus sine squared is the same thing as cosine squared. So I could change this numerator to cosine squared. And then we can manipulate it a bit. You don't necessarily have to show this next step, but cosine squared is the same as cosine times cosine. If I kind of strategically mark those, you can see then that it is cosine times cotangent. I would just continue to encourage you that when you are verifying, your last line should say exactly what the other side started out as. We don't want to change the other side. We don't want to stop short of getting all the way there. So making sure that we are actually getting our last line to be a duplicate of the other side to say we are done. All right. Today, we are going to find the solution to trig equations. This is kind of what we've been building up to a little bit. A lot of things in the world are described using equations that involve trig expressions. And so this becomes something that shows up a lot more. We will also kind of be revisiting the idea of inverse trig a little bit. And you do need to make sure that you remember your method for finding unit circle values, whatever that method was. So if you are a memorizing quadrant 1 type of person, what you might want to do at this moment is draw yourself a quadrant 1 because we're going to use it all day. If you are a special right triangles person, that you are going to go draw your 2 models for the special right triangle so that you just have them to reference because we are going to use them with every problem. And if you are a hand trick person, there's nothing to draw. So we'll revisit our hand trick here in a little bit. It's similar to the idea of inverse trig, is that we're going to have these expressions with trig equations in them, and we're going to, or these equations with trig expressions in them. And at the end of it, we'll say, okay, hey, where do we get these answers? And what angle gave me that? So first of all, again, well, there's my quadrant 1. But I want you guys to think about like that inverse trig idea. Whatever your method is, I want you to think through it and say, okay, thinking through my method, I did something, I had an angle, and it gave me an answer for my sine of 1/2. What was that angle? 30 degrees. Now, with that being said, note, all answers will be in radians. So 30 degrees or pi over 6. Very good. So that x must have been pi over 6. But what's different than inverse trig with solving trig equations is that the only place on our unit circle that sine would have had an answer of 1/2. Sine has an answer of 1/2, positive 1/2 at 2 places, doesn't it? Okay, what's the other one? Quadrant 2, right? So it would have been 150, or again, radians. What's the pi over 6 that's in quadrant 2? 5 pi over 6. So that would have been a second answer for us. So we would have had actually 2 possible correct answers for this, which would have been pi over 6, or it could have been 5 pi over 6. Both would have given us an answer of positive 1/2. Okay, well, guys, you just saw solving trig equations, a very basic one. But that's what it's getting at, is that we're going to get a trig function all by itself. We're going to have a value on the side and say, okay, what angle would have given us that value to solve these? Okay. Now, there are 2 different ways that you can think about this. We thought about one trip around the unit circle on the last page, right? We thought about that it was positive in quadrants 1 and 2, and so we picked answers from quadrants 1 and 2. We didn't pick answers from 3 and 4, but guys, remember when we drew our like sine graph a long time ago, and we drew a sine graph, that it actually continued on forever? So I drew a picture of a sine curve, here's sine of x, right? Does that look familiar? And then I drew that line of 1/2, which is this red line. Well, actually, you see how many places it's hitting my graph? Like a ton. And actually, neither of those lines stop ever. And so what's happening is there's two kind of different ways that they will ask us these questions. And it is like one trip around the unit circle, which is just from 0 to 2 pi, which would have just been here to here-ish. Those are the two answers we just got. But it continues to repeat and repeat and repeat and repeat if I were to continue to draw those two graphs forever and ever. And they repeat at a set interval, and it's every time we make that trip around the unit circle. So how do we represent all answers? Okay, and that is the fact that, first of all, we found our answers from 0 to 2 pi. We already did that. Thank you. And then we use the fact that a circle, a unit circle, has the same, or a sine curve, I should say, has the same period every time, and that is 2 pi. So every time I would go another 2 pi, remember those coterminal angles, every time I add another full circle, I would land at something that would still give me an answer of 1/2, and then go another full circle and get another answer of 1/2. So I can just add another full circle. The n represents as many full circles as I want. So if we were to go back to our solutions for this, we got a solution of pi over 6 and 5 pi over 6. But if I want to represent all, it's pi over 6, and then every full circle that I would make that would start at pi over 6, add another full circle, end up at a coterminal angle to pi over 6, gives me the same answer. Same thing for 5 pi over 6 is 2n pi. Adding full circles, and the n again just represents as many full circles in the positive or negative direction that I want to go. So when they ask us to find all solutions, we still just start by finding the solutions for one circle. But then we just tack on the, hey, yes, and every full circle I were to add or subtract to that answer would also give me an answer of 1/2. Now, please note that tangent and cotangent were kind of unique, and we didn't talk about them much because it didn't impact how we graphed them, but they don't have a period of 2 pi. They actually only have a period of pi. So if I were doing a tangent question, let's say, what's a tangent value that we could get? Square root of 3, okay? Well, tangent can be square root of 3. Go back to your method here. What angle gives us a tangent value of square root of 3? Pi over 3, yep, 60 degrees. And the other place that it is positive, here, let me give myself some room here. Quadrant 3, what's the pi over 3 in quadrant 3? 4 pi over 3. But notice the difference here is that if we do the all solutions for tangent and cotangent, because they have a period of just pi and not 2 pi, when I go to add this, it'll just be n pi instead of 2n pi because of the difference in their period length. Okay, so just a little special case there. You won't see these very often. Now, here's what I'm going to tell you, is we are going to continue to practice this a little bit with the whole all. You'll see it a couple times in our notes. We really more care about these values here, but it is important that you see this. A very specific reason. Somebody came back to me one year and said, hey, I'm so glad I saw this right before I took my entrance exam, because that exact question showed up on my entrance exam at, I think they went to UNL. And they said, and I knew they had the plus 2n pi there. And so I was like, man, I'm really glad we covered that, because normally I would just care about the pi over 6 and 5 pi over 6 part of it, but maybe you'll see it here in a little bit. Okay, so general reminders about our unit circle. Things that will help you through this is, first of all, remember what quadrants things are positive and negative. Okay, so that's what you're going to be looking at. I'm going to draw this little all students take calc thing on most of our problems today, just to make force myself to think about what quadrants should my answers be coming from. Where was this particular trig function positive or negative? And then I want to just take a second and remind ourselves of what type of answer I get from each of the 4 quadrants when I'm talking my radians. So in the first quadrant, obviously it is your basic answer, but I want you to think about how does it compare to my denominator as I move through each quadrant. For example, we talked about like pi over 6 in quadrant 1 and then 5 pi over 6 in quadrant 2. Remember that all of our radians for quadrant 2, your numerator is 1 less than the denominator. And it doesn't matter for any of our angles there. We only have 3 options, pi over 6, pi over 4, and pi over 3, right? But to move us into quadrant 2, it's 1 less than our denominator, 2 pi over 3, 3 pi over 4, or 5 pi over 6. To move into quadrant 3, how does it compare to our denominator? How does our numerator compare to our denominator? 1 more, right? The numerator is 1 more than the denominator. Specifically, 4 pi over 3, 5 pi over 4, and 7 pi over 6. I drew those out of order, but. And then to move into quadrant 4, do you remember what it always was? Full circle is double our denominator, right? And if I want to be just short of a full circle, I'm going to be 1 less than double our denominator. So again, those options would be if our denominator is 3, 2 times 3 is 6. 1 less than that would be 5. 5 pi over 3 would put us into quadrant 4. If our denominator is 4, double that is 8. 1 less than that is 7. If our denominator is 6, double that is 12. 1 less than that is 11. Guys, there's your like word bank for answers, right? It's going to come from this. Unless it's on an axis, you can go draw that picture for yourself of an axis. We'll get there when we hit an axis question here. But what I'm going to say is, okay, great. Our angle is pi over 3. What is the pi over 3 in quadrant 3? What is the pi over 3 in quadrant 4? And being able to think through that, okay? All right. Let's jump into some problems here. When we see these problems, remember the like sine of x, cosine of x, tangent x, all of those, they're like thinking of it as a variable. So this is similar to (3a minus 2 equals 5a minus 1), right? It's not a, it's sine of x, but I solve it just the same as I get my like terms on one side. I get everything else that's not on the other side. I get that like term completely by itself. And then we have to think through our unit circle, okay? So if I were solving this one, I would probably move to this side over here, like subtract that 3 sine of x. I'm going to show all my work on these first couple here so we don't get lost. I'm going to subtract 3 sine of x from both sides here. Add 1. And divide by 2. Okay. These are my helpful hints to you to help you be successful when you get to the end of this problem, because very commonly we will pick the wrong angles. But one of the things I want you to think about is at this point, when you have that trig function all by itself, I want you to think about the sign on that number, and you're all students take calc. Okay, we are saying that we have a sign answer that is negative. Of those quadrants, where could that be? 3 and 4. And this is the little picture you're going to see on most of my problems is I'll draw that little all students take calc and I'll circle where that answer can be. And then even more is that I'm going to say, okay, what is my answer that I got from quadrant 3 and what is my answer that I got from quadrant 4? Okay, now we go back to our angle. What is the reference angle that gives us a sine value of 1/2? We've kind of already talked about this. What is that in radians? Pi over 6. Okay, now translate that to the pi over 6 that's in quadrant 3. 7 pi over 6. Now, this one did ask us to find all solutions. If it doesn't narrow it down to just the 0 to 2 pi, all solutions mean I tack on the 2n pi. Oops. To every answer that I get. And I do the same thing then for quadrant 4. What is the pi over 6 that puts us into quadrant 4? 11 pi over 6. And then every coterminal angle to that, so plus 2n pi. And again, we put this plus 2n pi thing here because it said all. It did not narrow it down to just one trip around the unit circle, so I have to account for any coterminal angle to that. Questions for me? All right. Five sine of x equals 3 sine of x plus the square root of 3. So again, think about getting your like terms onto the same side of the equation. In this case, I would want to get my sine of x's onto the same side of the equation. And the way that this equation is set up, I would do that by subtraction, right? So I'm going to start by subtracting, and I'm going to move my sine of x's to the left-hand side here. So I'm going to subtract 3 sine of x. And you guys know by all of your algebra you've done over the years that there's not necessarily one right or wrong way to do this. We can move things differently, right? But we should end up at the same place at the very end. 5 minus 3 is 2. Continue solving. I want it to just say plain old sine of x, and right now it's 2 times the sine of x. Well, then that means I would divide both sides by 2. At this point, guys, this value over here should be one of those numbers that has just been staring at us over and over and over this year, right? If it is not, see if it'll simplify, or if we did something wrong or accidentally added or subtracted a number wrong, but it's at the end of this, you should be staring at a unit circle value, okay? And so then again, we pause and say, okay, well, where should my answers be coming from? This is a sign question and it's a positive number. What quadrants do I get answers from? 1 and 2. So I'm going to come down here and make sure that I tell myself, get an answer from quadrant 1, get an answer from quadrant 2. I put that down there purely as a reminder. It's not a requirement. It's just something that I found has made people a lot more successful in remembering that you have multiple answers and which quadrants those should be coming from. And again, it's an all solutions type of question. So that means I'm looking at all coterminals to that as well. Reference angle. What reference angle gives us a sine value of square root of 3 over 2? Pi over 3. And the pi over 3 that's in quadrant 1 is pi over 3 plus all coterminal angles. So plus 2n pi. And the pi over 3 that's in quadrant 2. 2 pi over 3 plus 2n pi. All right, questions? Okay, so our types of answers that we can have, we've seen the last 2 questions have said all solutions. So if we were looking at this problem that is above, and it says cosine of x equals square root of 2 over 2, first of all, that's going to, that's going to come from which quadrants? 1 and 4, okay? And the reference angle that gives us a answer of square root of 2 over 2, pi over 4. When it says all solutions, we must add in your 2n pi, right? So we would have pi over 4 plus 2n pi. And then what's the pi over 4 that's in quadrant 4? 7 pi over 4 plus 2n pi. But if they change the directions to just this 0 to pi over 2, guys, that's just your principal answers or your first trip around the unit circle. So it becomes just that pi over 4 and that 7 pi over 4. And you don't have to account for coterminal angles bigger than 2 pi. So it's the same thing. We do the exact same thought process. You just don't have to tack on the coterminal part of it. Okay, questions? easy to translate between the two. You just have to pay attention to which type of directions did they ask me for this particular question. Anyone still need this page? Okay, so let's try some that are on the interval from 0 to 2 pi. Ooh, and a reciprocal one. How do we deal with a reciprocal one? Oh yeah, I told you we might have changed things up a little bit. I did. Okay, so I don't know if this one shows up later on. Do we have one like this later on in our notes? Nope. All right. Sorry, guys. It's going to flow better if we just go with what I got here. So solve the equation anytime we have a reciprocal. So what am I talking about? I'm talking about a secant, a cosecant, or a cotangent, right? Anytime I'm talking about one of those three, what you need to think about is its reciprocal of tangent, sine, or cosine. Okay, your three basic ones. And so as we go back to that, well, you don't have to. I think it's easiest to think about that. I don't necessarily show this, but what I'm going to do is think about what these are as a fraction. So cosecant of x and 2, what can I write those as fractions? This is the same thing as 1 over sine of x, right? And 2 is 2 over 1, right? I just put this over 1. Those are the same thing, yes? When I get to this point and I have that reciprocal solved for, I think about what its reciprocal is, and I would then reciprocal both sides. If 1 over sine of x equals 2 over 1, that means that sine of x over 1 equals 1 over 2, or sine of x equals 1/2. If cosecant of x is 2, sine of x must have been 1/2. And typically we think through it better when it is the sine, cosine, or tangent. So you'll see that I'm always going to rewrite mine in that terms, sine, cosine, or tangent, because I can figure out that answer a little bit better. Which, man, we picked the same one over and over on this, didn't we? We're going to know this one really good. Still quadrants 1 and 2, right? We are only getting from 0 to 2 pi, so I don't have to worry about that whole plus 2 and pi thing, but I should have an answer from quadrant 1. Sine of x equaling 1/2, which we have now answered 3 times, I think, today. Sine of pi over 6, right? And then the pi over 6, that puts me into quadrant 2. 5 pi over 6. All right. Questions? So that's a way to handle a reciprocal. Now, if you can look at cosecant of x equaling 2 and recognize which angle it is that gives you that answer, you don't necessarily have to show that it's sine of x equaling 1/2. I just think that we think through sine of x equaling 1/2 a lot better. But especially my special right triangles people, you might be able to stay right here and answer what that angle is. So, all right. Let's look at another one. This one is going to require just a little bit of manipulating here. Yes, again, I think we've changed these to clean this up a little bit. So this one, it says 3 cotangent theta equals the square root of 3. So when I am attacking one with a reciprocal, I'm going to get that reciprocal function by itself. And again, if you can think through it as cotangent, go right ahead. I'm going to give you an option to look at its reciprocal. So if I solve this, first of all, I would divide by 3. And if at this point you are comfortable finding that theta, go right ahead. But you can also think about its reciprocal. Now, if I reciprocal both sides, the reciprocal of cotangent is tangent. The reciprocal of square root of 3 over 3 is 3 over the square root of 3. And that one is a little bit confusing. But sometimes you have to do just a touch of work at the end to continue to clean it up. This I would not have left. I would have rationalized. Well, 3 over 3 simplifies, and we're actually looking at the question, what is the tangent of theta? That gives us a square root of 3. Questions? Okay, so force yourself to think through. All students take calc. If it is a positive tangent, what quadrants should we have answers in? 1 and 3. Okay, so 2 answers from 1 and 3. Okay. We're only going from 0 to 2 pi, so I don't have to add in my plus 2 and pi. Okay, go to your method and find me the angle that gives us a tangent value of square root of 3. What is it? Pi over 3. Should be pi over 3. And in quadrant 1, that is pi over 3. But what's the pi over 3 that puts us into quadrant 3? Ooh, 4. 4 pi over 3. Questions? So again, at this point, depending on your method, my special right triangles people especially, you may not want to do this because you can look at your model and see the one that would have an adjacent side and an opposite side. Maybe they're not quite that way on your tangent and cotangent. But like my hand trick people probably will want to do that for sure. But you find the method that's going to be successful for you. All right. Try this one on your own, please. Can we please change it to something other than sine? Let's change this to a cosine. Change it to cosine. We've done that one already. We've beat that one to death, I think. Change this to cosine. All right, let's solve. If I leave it as -2/4, it's not going to appear to me what angle gives me that. So make sure that you're simplifying. Rationalize if that is appropriate. Simplify your fractions, because on the unit circle, everything is completely simplified and you would not recognize it unsimplified. So -2/4 is not on the unit circle, but its simplified version, 1/2, is. So then we force ourselves to think through our all students take calc, and the 2 quadrants where cosine is negative, you should have picked would be quadrants 2 and 3. So I should be getting answers from quadrant 2 and quadrant 3. The angle that gives us a cosine value of 1/2 should have been pi over 3. But pi over 3 in quadrant 2 is 2 pi over 3. And the pi over 3 that is in quadrant 3 would be 4 pi over 3. Now I started on the right-hand side here because I think you're thinking about the principal values that would put us in the unit circle. And then all I have to do is repeat those 2 answers for all and add 2n pi to each of them. And remember, that will only ever change to n pi if I had just done a tangent or cotangent problem, because they have a different period length. And so it would hit that value every n pi instead of 2n pi. But other than that, just tack a 2n pi on it. Any questions for me today? All right, you guys get a worksheet. Let me stop my video.